Hello, welcome to video. Gate questions on signals and systems. Presented by Ganesh N. Jadhav, K.K. Vag Institute of Engineering Education and Research, Nashik. This question is from Gate E 2024. Consider the discrete time systems T1 and T2 defined as follows. Which of the following statement is true? T1 and T2 are Bibo stable. T1 and T2 are not Bibo stable. T1 is Bibo stable and T2 is not Bibo stable. T1 is not Bibo stable and T2 is Bibo stable. Before we begin, let's quickly define Bibo stability. Bibo stands for bounded input, bounded output stability. A discrete time system is Bibo stable if, and only if every bounded input sequence yields a bounded output sequence. A signal is bounded if its absolute value is never greater than some finite constant. In simpler terms, a stable system ensures that a controlled, finite input will not cause the output to go out of control or diverge to infinity. Let's analyze the stability of system T1 by replacing the input x of k with the unit step sequence u of k. The unit step sequence u of k is a bounded input. The accompanying graph visually demonstrates the output T1 growing unboundedly with increasing n. If n approaches infinity, then the output T1 approaches infinity. Though the input x of k is finite, the output T1 is unbounded. Hence, T1 is Bibo unstable. This is because a bounded input resulted in an unbounded output. Next, let's analyze the stability of system T2, again by replacing the input x of k with the unit step sequence u of k. The accompanying graph visually shows the output T2 converging to 2 as n increases. If n approaches infinity, then the output T2 approaches the value of 2. Since the input x of k is finite, the output T2 is also finite. Hence, T2 is Bibo stable. Based on our analysis, T1 is not Bibo stable and T2 is Bibo stable. Therefore, the correct statement is T1 is not Bibo stable and T2 is Bibo stable.